Hello, my name is Kevin Day. This presentation is on 5G cellular network forensics. This presentation was part of my Secure Wireless and Mobility Technologies course from Metropolitan State University in St. Paul, Minnesota. The agenda is as follows: Introduction, LTE cellular network forensics, 5G cellular network forensics, legal and privacy aspects, and then the final thoughts, or the conclusion. Introduction. Cellular network forensics is a cross-discipline of digital forensics and cellular networks. The goal being is to investigate cellular network facilitated crimes under a legally obtained warrant for the purpose of a criminal reconstruction. These criminal activities can be carried out with direct network support, such as cellular networks, or incidental network to the crime using historical or user locations. Network forensics is a sub-branch of digital forensics which monitors and analyzes incoming and outgoing network traffic. The data they could be looking for could be data information gathering, such as ID activities from the traffic logs, legal evidence, or intrusion detection. The different network mediums they could be looking for could be Ethernet traffic, TCP/IP traffic, and internet or wireless networks. A cellular network is a cellular or mobile network that is a radio network distributed over land areas called cells, each served by at least one fixed location transceiver, known as a cell site or base station. In a cellular network, each cell uses a different set of frequencies from neighboring cells to avoid interference and provide guaranteed bandwidth within each cell. User equipment can communicate even if moving through cells during transmission. In cellular network architecture, a subscriber can gain access to a cellular network via radio signals by enabling a radio access network. The radio access network is connected with the wireline portion of the network, also called the core network. The core network functions include servicing subscriber requests and routing traffic. The core network is also connected to the public switch telephone network and the internet. The public switch telephone network is a circuit-switched public telephone network that is delivered using voice telephone calls on fixed landline telephone networks. The public switch telephone network uses signaling system number 7, which is a set of telephony signaling protocols defined by the International Telecommunications Union for performing telephony functions such as call delivery, call routing, and billing. Investigations. Prior to every investigation, operators and law enforcement agencies must establish forensic readiness to ensure secure investigations. This could include identification, acquisition, and delivery of cellular network evidence. These operators are realized with two forensic mechanisms: lawful interception and lawful access location services. The investigations in cellular network can be in real-time and non-real-time. Real-time being the level of computer responsiveness in that a user senses is significantly immediate, or that enables the computer to keep up with some external processes. Investigators work with evidence transmitting over the network at the time of the crime or attack. This can include outgoing calls, browsing sessions, or triangulated geolocation coordinates of a user. Non-real-time can be the event or process that does not occur immediately. For non-real-time investigations, investigators work with evidence in relation to past user activity, such as changing data records or user's most visited cell. The next section of this presentation is entitled LTE Cellular Network Forensics. LTE, or long-term evolution, sometimes called 4GE LTE, is a standard for wireless broadband communication, officially commenced in 2005. The two goals of LTE, the first one being increase the capacity and speed of wireless data using new digital signal processing techniques and modulations. The second goal being the redesign and simplification of the network architecture to an IP-based system with significantly reduced transfer latency as compared with 3G architecture. The specification allows for a download peak rate of 300 megabits per second and an upload peak rate of 50 or 75 megabits per second. Quality of service provisions permitting a transfer latency of less than 5 megaseconds. Lawful interception can be defined as a legally provisioned action performed by a cellular network operator to make the communications and communication-related information available to one or more law enforcement agencies. Each lawful interception is invoked for a target entity such as a suspected user or victim and/or target services such as all outgoing data or short message services. To distinguish between different lawful interceptions requests, the law enforcement monitoring facility uses a unique lawful interception identifier. This information, together with the time period for the interception and delivery information, is sent over the handover interface. Every operator has an internal administration function that takes the request provisions to the lawful interception to the interception control elements and configures the IP address of delivery interface. The lawful interception protocol stack, operators can intercept two types of cellular data, user traffic and signaling traffic. The intercepted user traffic is referenced as content of communication and delivered over the handover interface 3 in a predefined format to the law enforcement agency, such as audio or PCAP. The interception signaling traffic is referenced as the interception-related information and is delivered over the handover interface 2 in various IDR record types. There are 4 different types of record types possible. The begin record type is the first event of a communication attempt to the target identity. The end type is the end of a communication attempt closing the transaction for the target identity or service. Continue is the intermediary record at any time during a communication within the transaction, and the report record is for non-communication related events. Each record contains a unique correlated number, such as mobile identifiers, IP addresses, ports, access port names, dialed and connected number service cells, short message services, such as the sender, receiver, or even the content, as well as the date, time, and duration of events. For non-real-time investigation, investigators have altered to use the IRI records in conjunction with the changing data record generated for each ICE for changing purposes. The changing data records contains a small information as the records are often used in investigations because they can be obtained offline from the operators. Content of communication. This content of communication data represents the actual user traffic that is realized over the cellular network by the target identity. Voice conversation, inception, and delivered formats, and IP sessions delivered and packet captures. Forensic speak recognition techniques. Acoustic techniques rely on experienced human perceptions in matching the interpreted voice, content of communication, and record voice based on the phonetic similarity between the two sources. Auditorio instrumental techniques employ statistical analysis of common voice features such as the average fundamental frequency, actuary rate, format, central frequencies, rhythm, and voice quality. Automatic forensic speaker recognition works by extracting voice features of a training set of speech data to model different speaker patterns that are later compared with the feature of extraction of intercepted voice content of communication to yield a similar score with the target speaker. Lawful access location services. Legally provisioned actions performed by a cellular network operator to make location information available to one or more law enforcement agencies. Cellular network provide location services that utilize the geographic location of the user. For this purpose, cellular networks implement a location service architecture with location measurement units in the radio network to execute the localization, measurement, and service mobile location services in the core network to communicate the location information with the location service clients. The service mobile location centers communicate with the localization request using the LPP protocol to the localization measurement units, in which turn coordinate with the target entity to calculate their current location. This location information can be provided to external entities. User location is calculated using either of these localization methods. Exclusive chip identification. The coordinates of a cellular device are derived by measuring either the round trip time or the angle of arrival or of a reference signal between one or more three base stations in the cellular device. This is triangularization. The precision of this can be between 50 meters and 1 kilometer. Time to fix first is less than a few seconds for more than 90% accuracy. The observed time difference of arrival. Positioning feature introduced in the LTE radio. The mobile device measures the time of arrival for the download ring signals received from multiple base stations of at least 3 and subtract from a reference time of arrival from its serving station. This is multilateralization. Each of the received signal differences measures described as a hyperbola or ellipsoid ID. The intersection of their focal lines provide the coordinates of a cellular device. Precision of this is less than 50 meters, and the time to first fix of around 10 seconds, but less than 70% accuracy. Service mobile location centers. Administrative function. Lawful access location services. Cellular Internet of Things is a generic term used to describe a number of cellular-based technologies in support of IoT operations. Network features primarily defined in a LTE Advanced to enable license and spectrum for a massive number of IoT devices. This can be implemented in 3 different varieties. Extended coverage Internet of Things. This could be standard-based low-power wide area technology based on the EGRS PN design is high-capacity, long-range, low-energy, and low-capacitor cellular systems for IoT communications. GSM has the largest global coverage footprint in a very small time to market, which is a huge advantage for ready available IoT applications. This could be coverage extensions, LTE-grade security, and improved power efficiency for legacy machine-to-machine communications. It's enhanced machine-type communications. The adaptation of the current LTE access to accommodate COIT applications such as wearable technology, CCTV, object tracking, and smart healthcare. It enables 15 dB enhancements sent over the standard LTE coverage and extended to the DRX to relax the latency and provide bigger delay budget needed for many CIoT applications. Fully compatible with the standard LTE Advanced architecture, making it relatively easily to support the current deployed LTE networks. Narrow bandwidth IoT. Low power wide area network radio technology standard developed by 3GPP enables a wide range of cellular devices and services such as indoor coverage, low cost, long battery life, and high connective density. Uses a subset of LTE standard but has limited the bandwidth to a single narrow bandwidth of 200 kilohertz and uses a modulation for download communication links and FIDMA for upload communications. IoT applications which require more frequent communications will be better served by narrow bandwidth IoT, which has no duty cycle limit operations on the licensed spectrum. Lawful interception and adaptation for CIoT. In the CIoT case, the CSGN accepts the lawful interception request and configures the ICE depending on whether the COIT user traffic, signaling traffic, or both are needed. CGSN is needed to configure a CIoT identifier to the law enforcement agency to distinguish it from the IDR records or CC data intercepted for the non-CIoT users. The administrative function can remove this number to a CGSN depending on a location network mapping of specific mobile identifier numbers specifically identical to the COIT devices. Operators usually distinguish between the different user groups by specific mobile identifier series. Can cause confusion in cases where a user inserts a regular SIM card into a COIT device. Investigators need to be aware of such anti-forensic actions. Lawful access identification services adapting for COIT. These general LSC architecture for LTE and LTE Advanced require adaptations to enable LAS provisions for CIoT devices. The limited computational and memory resources restricted to these devices perform the immediate positioning measurements while they are in a connected state, which is a prerequisite for most of the positioning procedures. Therefore, CIoT devices need to be allowed to perform measurement in an idle state when they have at most their resources available. Lawful access services for adapted COIT. Service mobile location centers use a flag to indicate a support for an idle state measurement. In this case, the positioning measurement are performed in idle and communicated back in a connected state. The Service Mobile Location Center accommodates this prolonged with a extended timer depending on the COIT application. And now this is the legal and privacy aspect section. Cellular network forensics in the European Union use the use of lawful interceptions, and within the European Union is covered by Council Resource 97-C321-01, requires the law enforcement agency to access all IRI records and CC data from a user and signal traffic transitioning or stored by a cellular network, as well as requested subscriber localization information. Some EU directives should be the 95-46/EU, such as the Data Protection Directive, protects the protection of individuals with regard to the processing of personal data on the free movement of such data. The 2002-20-EC Directive, such as the authorization, establishes a guideline concerning the cooperation between the law enforcement agencies and cellular network operators, which law enforcement agents for lawful inception is a condition for granting cellular networks the authorization to operate. The This also contains several conditions that may be attached to the general authorization providing a lawful inception in conforming with the Directive 97-66 EC. In the U.S., on the other hand, we have the Commission on Accreditation for Law Enforcement Agencies that require that law enforcement agencies need to be able to access IRI records and CC data with no degradation and interference to the subscriber service while protecting the privacy and securing of subscriber and the represented interception material. The Wiretap Act includes the Title III of the OCCSA and the ECPA, prohibits the unauthorized, non-consensual interception of wire or electronic communications by government agencies for the target identities that are U.S. citizens. There's also the Foreign Intelligence Surveillance Act, FISA, which covers the use of lawful inception and law enforcement agencies for the intelligent purposes for which their target identities could not be a U.S. citizen working as an agent on behalf of a foreign country. The invocation of lawful inception under the FISA requirements prior authorization by a FISA federal court. The U.S. Patriot Act Title II allows law enforcement agencies to obtain authorization for lawful interception by demonstrating that the IRI or CC records are relevant for an investigation, rather than stricter FISA requirements to demonstrate that the target identity is explicitly involved in unauthorized activities and terrorism. Cooperation Cellular Network Forensic Investigations. In general, prior to lawful inceptions are invoked, the law enforcement agency must obtain a court warrant and implied private protection for safe and storage and analysis of the acquired cellular network evidence. Warrantless invocation of lawful interception is possible if it is determined that emergency existence involves immediate danger of death or serious physical injury to any person, conspiracy activities threatening the national security interests, or conspiracy activities to characteristics of organizational crime. The LEE, such cases needed to apply for a warrant approving the interception within a few days after the lawful interception and the evidenced acquisition has occurred to the appropriate court, with the appropriate increase for the use of COIT in the future. Digital witness methodology. Warrantless acquisition of cellular network evidence proposed in that enables citizens to share their CIOT data with some privacy guarantees. A CIOT device can be a digital witness with the capacity of identifying, collecting, and safeguarding and communicating cellular network evidence. The digital witness is harmonized with the ISO IES 29100 privacy principle to stimulate the cooperation of citizens in forensic investigations. This is an interesting and promising approach to augment COIT and lawful inceptions. However, the law enforcement agency must be able to corrective and possibly verify the evidence material collected from the CIOT digital witness from the material acquired from the network operator. And lastly, this is the conclusion. In CUPS, network slicing and COIT are developed largely in isolation, so irregular that 5G ecosystems will impact the continuous support for lawful interceptions. Different correlation and mechanisms per technology, multiple streams of IRI and CC records, and portional inclusions of third parties in the cellular service revelations are just some of the new challenges law enforcement agencies need to address to keep the lawful interception capabilities in the future 5G networks. Equivalently relevant is the legal aspect of conducting cellular network investigations with the traffic served by virtuals functions that can reside in multiple jurisdictions. Law enforcement agencies also need to find a way to continually support lawful interception, especially for real-time investigations. On top of this, law enforcement agencies are increasingly challenged with the aspect of third-party encryption CCs, which depend on the jurisdiction that might preclude law enforcement agencies to decrypt the user traffic of interest. Thank you, and I hope you enjoyed this presentation.